Good morning, students. Last time we have completed nomenclature of organic compounds, in which we have seen IUPAC nomenclature of saturated hydrocarbons, unsaturated hydrocarbons. Then we have seen the nomenclature of monofunctional group compounds. Then IUPAC nomenclature of polyfunctional group compounds. After that, we have seen the IUPAC nomenclature of aromatic compounds, in which we have seen IUPAC nomenclature of monosubstituted aromatic compounds, disubstituted aromatic compounds and trisubstituted aromatic compounds. Now next point we are going to see is isomerism. Now the compounds having same molecular formula but different structural formulae are called as isomers, and this phenomenon is known as isomerism. That is, organic compounds can be represented by different structural methods but they have same molecular formula. These compounds are called as isomers of each other, and this phenomenon is known as isomerism. Now here the definition of isomerism is compounds having same molecular formula but different structural formulae are called isomers, and the phenomenon is known as isomerism. Now we can understand this term by using one example of butane. That is, the molecular formula of butane is C4H10, but the isomers or different structures of this butane are first one CH3, CH2, CH2, CH3. In this case, all the carbon atoms present in butane are in a straight chain. Therefore, it is called as N-butane. And second isomer or second structure of this butane is CH3, CH, CH3, CH3. Now here 3 carbon atoms are in a straight chain and 1 carbon atom forms a branching with middle carbon atom. This is isobutane. Now these two compounds have same molecular formula, that is C4H10, but their structures are different. Therefore these two compounds are isomers of each other. These two compounds are isomers of each other. They have same molecular formula but different structural formulae. Now there are two types of isomerism. First is structural isomerism and second is stereoisomerism. In structural isomerism, compounds having same molecular formula but they have different structural formulae or different structural representation. These compounds are called as isomers of each other, and this phenomenon is known as structural isomerism. And in case of stereoisomerism, compounds have same molecular formula, they have same structural representation, but arrangement of atoms or groups in the space are different. These isomers are called as stereoisomers, and this phenomenon is known as stereoisomerism. Now there are 5 types of structural isomerism. First is chain isomerism. This chain isomerism generally present in saturated and unsaturated hydrocarbons. Then second is position isomerism. Position isomerism is present in case of unsaturated hydrocarbons, that is alkenes or alkynes. Then functional isomerism. This functional isomerism is present in the compounds having functional group. Now here the compounds have same molecular formula but they have different functional group. Then 4 number is metamerism. This metamerism is generally present in ethers and in case of ketones. And last one is tautomerism. Tautomerism is present in case of aldehydes or ketones. Then stereoisomerism, in which first is geometrical isomerism. Geometrical isomerism generally present in alkenes There are two types of geometrical isomerism, cis and trans isomerism, and second is optical isomerism. This optical isomerism is generally present in the compounds having chiral or asymmetric carbon atom. Now we are going to discuss all these types of isomerism in detail. First we are going to see the structural isomerism, that is types of structural isomerism. Now the structural isomers are the compounds having same molecular formula but they have different structural formulae. It is called as structural isomers and the phenomenon is known as structural isomerism. In which first point we are going to see, or first type of structural isomerism is chain isomerism. Now in case of chain isomerism, when two or more compounds have same molecular formula but different parent chain or carbon skeleton are called as chain isomers and the phenomenon is known as chain isomerism. Now here we are going to understand this type by using example of pentane. Now the molecular formula of pentane is C5H12. Now there are three structural isomers or chain isomers of pentane. Now first one, if all the 5 carbon atoms are in straight chain, then it becomes CH3, CH2, 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 CH3. All 5 carbon atoms are in a straight chain. That is parent chain is of pentane. N-pentane. All 5 carbon atoms are in straight chain, therefore it is normal chain, therefore it is N-pentane. Now second isomer of this pentane is CH3, CH, CH3, CH2, CH3. Now in this case, 4 carbon atoms are in straight chain and 1 carbon atom or 1 methyl group forms a branching. Now here it is isopentane or it is parent chain is butane, parent alkane is butane and at 2 position there is methyl group, therefore it is 2-methyl butane or common name of this compound is isopentane. And third isomer in which here 1 carbon atom is bonded to 4-methyl group. That is 1, 2, 3, 4, 5. 5 carbon atoms in which 1 carbon atom is bonded to 4-methyl group. This is neopentane or IUPAC name of this compound. Now here parent alkane is propane, 1, 2, 3, propane and at 2 position 1, 2, 3, 1, 2, 3, at 2 position there are 2 methyl group, therefore it is 2,2 dimethyl propane. In this way this pentane possesses these 3 isomeric forms in which in first structure all the 5 carbon atoms are in straight chain, that is parent alkane is pentane. In second structure parent alkane is butane and 1 alkyl group or 1 methyl group is bonded to or branched with this butane chain, and in case of third isomer 3 carbon atoms are in straight chain, that is parent alkane is propane and at 2 position there are 2 methyl group, that is branching of 2 methyl group. This is called as chain isomerism. This is the example of chain isomerism. That is in chain isomerism either the hydrocarbon compounds are in a straight chain or in a branched chain. Now second point we are going to see, or second type of structural isomerism is position isomerism. Now this position isomerism generally present in alkenes and alkynes. Now here compounds having same molecular formula but in structural formulae the position of double bond or triple bond or functional group is different are called position isomers and the phenomenon is known as position isomerism. Now we can understand this position isomerism by using the formula of butene. Now butene, En stands for having double bond. Now the molecular formula of butene is C4H10. Now we can write the structure of butene. 1, 2, 3, 4. Now here there is Ene, that is there is one double bond, C double bond C. Now this is 1, 2, 3, that is CH3, CH, CH double bond CH and CH3. This is one isomeric form in which double bond is present at two positions, 1, 2, 3, 4. This is but. Parent alkene is butane, but there is double bond, therefore it is butene, Ene. But at two positions there is double bond, therefore it is but 2 Ene. This is one isomeric form. And in second isomeric form, here the position of double bond is changed like this. That is, here there is double bond. Then CH2, double bond CH, CH2, CH3. Now here there are 4 carbon atoms and the double bond is present at in between 1 and 2 number carbon atom. Therefore it becomes but 1 Ene. That is, this is the second isomer of butene. That is, these are the 2 isomers of butene in which the position of double bond is changed. In but 2 Ene, double bond is present in between 2 and 3 number carbon atom, and in but 1 Ene, double bond is present in between 1 and 2 carbon atom. This is called as position isomerism, in which the position of double bond or triple bond or functional group is different. Next type of structural isomerism we are going to see is functional isomerism or functional group isomerism. In this, compounds have same molecular formula but they have different functional groups, are called as functional isomers or functional group isomers, and the phenomenon is known as functional group isomerism. Now look here, the compounds having same molecular formula but different functional groups are called functional group isomers, and the phenomenon is known as functional group isomerism. For example, now we can understand this concept by using an example of compound having molecular formula C2H6O. Now this compound have molecular formula C2H6O. Now here we can write this structure like this: CH3, CH2, OH. This is alcohol. That is, functional group of this compound is alcohol. Name of this compound is, common name is ethyl alcohol or ethanol. IUPAC name is ethanol. And second isomer of this compound is CH3OCH3. It is dimethyl ether. Now both these compounds have same molecular formula, that is C2H6O. Look here, 1, 2, then 1, 2, 3, 4, 5 and 6. That is C2H6 and O. Now in this case 1, 2, C2, H6 and O. That is, these two compounds have same molecular formula but their functional groups are different. In ethyl alcohol there is hydroxy functional group. In dimethyl ether there is O, that is etheric functional group. Therefore these two compounds are functional isomers of each other or functional group isomers of each other. This is functional group isomerism, having same molecular formula but they have different functional group. Then second is metamerism. Now in this case, in metamerism, compounds have same molecular formula. They have same functional group but they have the unequal distribution of carbon atoms on the either side of functional group. That is, on the both side of functional group there is unequal distribution of carbon atom. Now we can understand this metamerism by using the example of ether. Now, in case of ether, we are going to see the molecular formula of ether is C4H10O. Now, in this case, we can write the structure of these ethers or isomers of ethers in two different ways. Now, here there are 4 carbon atom, 10 hydrogen atom and 1 oxygen atom. Now, we know that the functional group of ether is O. Now, there are C4H10. Now, if there are C2H5 group on both sides of this oxygen atom, then this molecular formula of this ether becomes C4H10O. This is diethyl ether. Now we can write the second isomer of this ether. Now here this oxygen is bonded to CH3 group and on the other side it is bonded to CH2, CH2, CH3 group. Now in this case this oxygen is bonded to methyl and N-propyl group. Now the molecular formula of this ether is C4H10O. This is methyl N-propyl ether. Now here this is simple ether, this is mixed ether. Now in case of diethyl ether, the oxygen atom is bonded to 2-ethyl group and in case of methyl N-propyl ether, oxygen atom is bonded to methyl and N-propyl group. Now these two isomers have same molecular formula, that is C4H10O. That is, in this case, in this diethyl ether, oxygen is bonded to 2-ethyl group and in this case oxygen and atom is bonded to methyl and N-propyl group. Therefore, these two isomers are metamers of each other. This is the example of metamerism. Now, last type of structural isomerism is tautomerism. Now, this type of isomerism or this tautomerism generally exhibit in the aldehydes or ketones. Now, we can understand tautomerism by an example. Look here. Now, here this carbonyl compound, which is bonded to this alpha carbon atom, which is bonded to hydrogen atom. Now in this case, this is keto group, carbonyl group or keto group. This carbonyl group is present in carbonyl compounds like aldehydes, ketones or carboxylic acid. Now in this case, this oxygen atom is more electronegative. Therefore, it withdraws electron from this carbon atom like this. And therefore, electronegativity of this carbon becomes less. That is, it becomes electropositive. Therefore, it withdraws electron from this carbon atom. And thus, this hydrogen gives these 2 electron in between these 2 carbon atom and it removes as a H plus ion. Now when this electron pair gets shifted in between these 2 carbon atom, then there is formation of a double bond and this H plus ion is removed which get attached to this oxygen atom like this, and here formation of hydroxy group takes place. This keto group is converted into hydroxy group and here double bond is obtained. Now this is keto group or keto form. It is converted into enol. Enol means having double bond. Here there is double bond ENE. Replace this E from ENE by OL. It is enol form or enol group. This is enol form and this is keto form. Now in this case, this keto form is in equilibrium with enol form. That is, in carbonyl compounds, such keto-enol equilibrium is observed. These two forms are in rapid equilibrium with each other. That is, this keto form rapidly converted into enol form, and this enol form rapidly converted into keto form. That is, there is equilibrium between these two forms. This type of isomerism is called as tautomerism. Now here some compounds exist as a mixture of two or more structurally distinct molecules which are in rapid equilibrium with each other. This phenomenon is known as tautomerism. Generally, tautomerism is observed in case of carbonyl compounds like aldehydes or ketones. This is also known as keto-enol tautomerism. Now we are going to see stereoisomerism. Now there are two types of stereoisomerism: geometrical isomerism and optical isomerism. Optical isomerism is not included in our 11th standard syllabus. We are going to discuss this optical isomerism in 12th standard in halogen derivatives topic. Now here we are going to discuss geometrical isomerism. This geometrical isomerism also included in hydrocarbon topic under the alkenes. Now here we are going to see the example of this geometrical isomerism. Now in case of stereoisomerism or in geometrical isomerism, compounds have same molecular formula, same structural formula, but the arrangement of atoms in the space are different. It is called as stereoisomerism. In geometrical isomerism, the geometry of the isomers are different. Now we are going to understand this geometrical isomerism by the example of but2-ene. Now but2-ene, molecular formula of butene is C4H8. Structure is four carbon atoms are in straight chain. At two position there is double bond, that is CH3, CH, CH, CH3. This is the structure of but2-ene. Now in this case, when the atoms attached to the double bonded carbon atoms or groups attached to the double bonded carbon atom are, these atoms or groups have different geometry like this. If the similar groups lie on the same side of double bond like this, CH3, CH3. Now this carbon atom is bonded to hydrogen atom, CH3 group. This carbon atom is bonded to hydrogen and CH3 group. If the similar groups means these two CH3 group lie on the same side of the double bond like this, then this isomer is called as cis isomer. And if the similar groups lie on the opposite side of double bond like this, then it is called as trans isomer. That is, this is cis but2-ene and this is trans but2-ene. In cis isomer, similar groups lie on the same side of double bond. That is, this CH3 and this CH3 are present on the same side of double bond, and these two hydrogen atoms are present on the same side of double bond. And in case of trans isomerism, similar groups lie on the opposite side of double bond. That is, this CH3 group present at this position and exactly opposite the CH3 group is present on that side. In this way, here similar groups lie on the opposite side of double bond. This is called as trans isomer. That is, in geometrical isomerism, the compounds have same molecular formula, same structural formula, but geometry of the atoms or groups in the structure are changed, like cis isomer and trans isomer. These are the types of structural and stereoisomerism. Optical isomerism we are going to discuss in 12th standard. Thank you. Complete the given homework and submit it on Google Classroom. Thank you.